Now we are going to learn about full wave rectifier. In the previous video, we have learned about half wave rectifier, wherein half of the wave is converted as a DC signal. Okay, only positive half cycle is converted as a DC signal. Now, in this full wave rectifier, this complete positive half cycle as well as negative half cycle will be converted as a DC. Okay, so that is what we are going to see. The circuit diagram for the full wave rectifier is this one. Okay, so it consists of a transformer and two diodes D1 and D2. As we have learned in a full half wave rectifier, this is the primary circuit and which is connected to a AC signal, and this is the secondary circuit which is connected to two diodes here. Okay, here we have connected to two diodes. Now from the center of our transformer, we have taken a connection, that is a center tap, we say. From the center tap, we have taken a connection to a resistor and it is connected to two diodes. Okay. Now during a positive half cycle, let us see what happens during a positive half cycle. During a positive half cycle, this point will become a positive and this point will become a negative. Then diode will be forward bias. So when diode is forward bias, what happens? The current flows through the diode and it will flow in this direction. And what happens to a diode D2? So this is the reverse bias. There is no current flow in the diode D2. Okay, only the current will be flowing in this direction. So for a negative half cycle, let us see. For a negative half cycle, what happens here? This will become negative and this will become a positive. Then what happens? Then this D2 will be in forward bias. So this D2 will conduct now. So this D2 will conduct the current. So the current will be flowing in this direction. Okay. So what happens to our D1? D1 will be reverse bias. Since it is a negative, there is no current through the D1. Okay. So that is how it works, and it will give the output as when like in either way, in either in positive half cycle or negative half cycle, the circuit will be the current will be flowing in the circuit. Okay. For a positive half cycle, the D1 will conduct and we have an output as this one. Okay. And for a negative half cycle, the D2 will conduct, there is a output current. So like this, the current will be there in the circuit throughout the like positive and negative half cycle. Okay. So let us see the working of it. Now, so this is the working clip. Let us see how it conducts. So positive, this is a positive half cycle. Diode 1 will be conducting. For a negative half cycle, diode 2 is conducting. So this is how the current flows in both the cycle, positive as well as negative. We obtain a output waveform for both the cycle. So this is the first way, the positive half cycle, we get a output, and for a negative half cycle, we get a output. So let us understand in full wave rectifier, the rectifier which converts both. Okay, both means both the cycle, this both half cycle is converted to a DC. That is called as a full wave rectifier. So let us see in this what is the changes in the circuit diagram. The main difference between a half wave and full wave rectifier in the circuit is the usage of two diodes. So in a full wave rectifier, it is we will be using two diodes, that is D1 and D2. Working. Let us see how this full wave rectifier work. Okay. So case 1, during a positive half cycle. So what happens during a positive half cycle? The diode D1 will be forward bias. Then what happens to a current? Will the current will be flowing in the circuit? Yes, there is a current flow in the circuit. Next, D2 is a reverse bias. So D2 will not conduct. Okay, D2 will be in reverse bias. There is no conduction happens in case of D2. Then we get an output that is measured across the load resistor. Okay, so across the load resistor, we are measuring the output waveform. Okay, so now case 2, the circuit diagram for a negative half cycle. Okay, in negative half cycle, let us see, in negative half cycle is fed to a full wave rectifier. So diode D2 is forward biased, right? The diode D2 is forward biased, hence there is a current in the circuit. So now what happens to D1? D1 is in a reverse bias and there is no current through a PN junction diode D1. So we get an output across a resistance, the load resistance. It is due to only D or D2, that means diode 2. So we observe that one of the diode conducts and the flow of current across the load resistance is in the same direction. Okay, the direction of current will be in the same direction across the resistor. So as the conclusion, so we have a positive half cycle, then the D1 will conduct. For the negative half cycle, the D2 will conduct. Let us see once again. So the positive half cycle, the diode D1 will conduct. For the negative half cycle, diode D2 will conduct. Again, it repeats. For the positive half cycle, diode D1 will conduct. For the negative half cycle, diode D2 will be conducted. Okay, thank you.